Grade 12, welcome back to the channel. We are back again with organic chemistry exam questions approach simplified part 3, and let's see the questions that we got. We have physical science chemistry, and I can see that's a Gauteng 2022 past paper. That was a prelim paper 2022 Gauteng, and let's see what we have got. The following types of formula represents organic compounds. Study the table below and answer the questions that follow. So we know the approach. So first thing that we're gonna do is check for any definitions. We want to whap the definitions very fast before we forget. So we check if there are any other definitions. 2.3.3. It says differentiate between the terms functional group and homologous series. So let's do that. Says functional group is an atom or a group of atoms that determine the physical and chemical properties of an organic compound. Then homologous series is a group of organic compounds that can be defined by the same general formula where each member differs from the previous by a CH2 group. Now coming back to the approach, we don't dadazel, we just zazazel. So we come here and we say, okay, let's name the homologous series of each and every organic compound that we see here. So the OH, the hydroxyl group here, it's telling us that this belongs in the alcohol, right? Then from here we can see the ester link. The ester link, it's telling us that this is in the ester homologous series. Then when we come to compound C, we can see the carboxyl group, which tells us that this is in the carboxylic acid homologous series, right? Then D, we can see the OH there. So alcohol. Then E, 2,4-dimethyl pent 1-ene. We can see you, you're an alkene. You're an alkene because of the suffix in. Then 2-methyl-propan 2-ol, all gibujwala. Then it's alcohol. Then G, we can spot a bromo there. So once you spot a bromo or a chloro, then it's definitely a haloalkane. Habashwe. Then let's commit first degree murder here. Then 2.1 from the table above, consider compound B. But write down 2.1.1 the homologous series to which compound B belongs. Now we can see that from this approach we have already wrote that compound B belongs in the ester. Then 2.1.2 says the IUPAC name of compound B. Now you will remember every time when we name an ester, we start from the side of the alcohol. Now we know the side of the alcohol is this one, whereby the carbon will be directly connected to the oxygen there. So we can see that the alcohol that was used there has only one carbon, which means it's methanol. So removing the anol from methanol, we have methyl. So here we have methyl. And then we can see the carboxylic acid that was used there has 3 carbon atoms. So removing the anoic acid from propanoic acid, now we have methyl propanoate. So that is the IUPAC name of this ester, compound B. Now 2.2 says an alcohol and an acid. An alcohol and an acid are heated in the presence of a concentrated sulfuric acid to form compound B, right? So we already know what is happening here. Once you take an alcohol and you react it with an acid, we know that we are trying to form an ester, that is esterification. Then 2.2.1 says the role of the concentrated sulfuric acid in this reaction. What does the sulfuric acid do? Now we know it acts as a catalyst. What does a catalyst do? It speeds up the chemical reaction, then acts as a catalyst. So we say it acts as a catalyst. caterpillar. Then 2.2.2, it says the names of the alcohol and the organic acid used to prepare compound B. Duh, we already said that. So from the name we can see it's methyl propanoate. So we know the alcohol that we use there. Let me erase here. So remember from the name methyl propanoate, we can get the reactants here. So remember, methyl comes from the alcohol methanol, so that means the alcohol that we use is methanol, and then the carboxylic acid that we used is propanoic acid, habash. Then 2.2.3 says name of the type of the reaction that is taking place. First degree murder batu. Then this is esterification. So we whapped through that question. Let's see, does it continue? Yes, it's not the end of the question. Then it says from the table above, consider compound C. Let's see what we got for C. Then compound C, we said that's the carboxylic acid. Yes, okay. Then write down the name of the functional group of compound C. Now if we say compound C is carboxylic acid, the functional group of the carboxylic acid is what? Is the carboxyl group. Then 2.3.2, to which homologous group does compound C belong? We already did that. So it belongs in the carboxylic acid. Now 2.3.3, differentiate between the terms functional group and homologous series. We already did that. We whap through the definitions from the beginning. Then 2.4, from the table above, consider compounds A, D, and F. Let's see. Okay, let me erase here first. A, D, and F. So, A, D, and F. A, remember we had alcohol because of the OH. D, also alcohol because of the OH. And also F, it's what? Alcohol because of the ol. Then they say, write down the homologous series to which they belong. Soft. 2.4.2, compound A and D are isomers. As what type of isomers will they be classified? Now we know we have three types of isomers: chain isomers, positional isomers, and functional isomers. Now we want to find out A and D, what type of isomers are this? So now we can see with A, the OH here. Okay, let's see, where's the OH in the first carbon? And with D, we can see the OH is attached to the second carbon. What is that? It's positional isomer. Same general formula, belong in the same homologous series, but have different position of the functional group. So we say that is the isomers is positional isomers. So the only difference is in the position of the hydroxyl group. Positional isomers. Now they say draw the structural formula of compound F. Wozala. Compound F is 2-methyl-propan-2-ol. 2-methyl-propan-2-ol. So when we draw, we want to see the longest chain propan. So that's 3. So let's go. We have 1, 2, 3, right? Then the OH is on the second carbon. Remember, propan-2-ol, and then 2-methyl. They said 2-methyl, meaning that also on the second carbon we have the methyl branch. Then that's how we go. That's how it goes. So that's 2-methyl-propan-2-ol. That's your structural formula. Now let's go. Then 2.5 says write down 2.5.1 the IUPAC name of compound G. Let's see compound G, 3 marks. So first we want to identify the longest chain in here. So let's count. It's 1, 2, 3, 4, 5, 6. So even if you curve it like that, it's still 6. So we'll just take the straight chain. So that's 6 hex. Now remember the rule of preference. We said the alkyl groups will always have first preference over your halogens. So that means numbering will start from which side? Numbering has to start from this side here. So this is carbon 1, 2, 3, 4, 5, 6, right? Because the alkyl groups always have first preference over your halogens. So that means the name that we have here is, we have a methyl branch in carbon number 2, also another methyl branch there. So we have 2 methyl branches in carbon number 2, and then we have our bromo in carbon number 5. So remember, but then the alphabetical order rule says that B comes before M, so that means we have to start with bromo. So that's 5 bromo, and then we have 2 dimethyl, and then how many? For compound G we said 6, so it's dimethyl hexane, right? So 5 bromo, 2 dimethyl hexane. Awesome. Then 2.5.2, it says structural formula of compound E. Structural formula of compound E. So we have 2,4-dimethyl pent 1-ene. So we want the longest chain, it's pent. So we want for the longest chain, pent is 5. Then it's 1, 2, 3, 4, 5. Then let's look at the positions. We have 2 and 4. So a methyl branch in 2, and also another methyl branch in carbon number 4. So we have that's 2,4-dimethyl pent 1-ene. So we have a double bond. Alkene, we have a double bond in carbon number 1. So where are we gonna put that one? So here carbon number 1, it's here. Then we can just fill in our hydrogen atoms where needed. Fill in our hydrogen atoms. First degree murder, baba. Fill in our hydrogen atoms, and like that you have your structural formula. It's correct, it's looking nice, perfect, nice one.